Our lecture today is going to be kind of short, you guys, because we're going to just do one thing. We're going to do the reverse of percent composition. All right. What if, percent composition, we said you can find the percent carbon, oxygen, hydrogen, copper, whatever. And all you have to do is take the individual amount divided by the total. Now, what if you get given the percentages and you have to figure out what the compound of the formula is? And this is what a lot of the fancy machines you see like on the crime shows, like the mass spectrometer and the infrared spectroscopy and all those, what they do is they can analyze the percent of copper, carbon, whatever, and they have databases. So if they find out it has so much carbon, hydrogen, nitrogen, oxygen, they can tell you, oh, this mystery substance is cocaine or it's baking soda, whatever. So I'm going to show you how to do this the short or the longhand way, I guess. But if you're given the percentages, you can find the actual formula, and it's kind of the reverse of what we did with percent composition. And it's called empirical formulas. Okay, empirical formulas and simplest formula mean the same thing. Okay. All right, so if we're going to calculate an empirical formula, what's going to happen is you're going to get the percent, you're either going to get the mass or the percent, and it doesn't matter. It might say, 24 grams carbon, 14 grams hydrogen, or it's 23% carbon, and it doesn't matter, you guys. Either way, you're going to get the same answer. So if you got the percent, what you're going to do is the first thing you got to do is you got to find the moles, excuse me. You need to find the amount of that. So what you do is you take the percent or the mass that they give you and you divide by their mass from the periodic table. Because what this is going to do is give you the moles. It'll tell you how many moles. Then what we're going to do is we're going to set up a ratio. We're going to put the smallest number on the bottom. And the reason we do that is we can't have a number less than 1. Remember, when we do subscripts, they're whole numbers. So if we do we don't do the smallest number when we divide, excuse me, we're going to get a number less than 1, and we can't have that. So we always divide by, our mole ratio is the smallest number on the bottom when we do our mole calculations. And then we put each individual ones on top, we divide them out, and we're going to get numbers. And again, from that, I can show you how to get your empirical formula. Okay, so you're given the percent composition. Now you got to figure out the formula. You're going backwards. All right, here we got a compound, para-aminobenzoic acid. Woohoo, it's PABA. You'll see it on your sunscreen. I think they put that now on like a lot of the different plastics and stuff. You'll see PABA free and all this other stuff. Supposedly, I don't know if it's bad for you or what. But anyway, it's made of carbon, 61.31% carbon, 5.14% hydrogen, 10.21% nitrogen, and 23.33% oxygen. Okay, so common substance, carbon, hydrogen, nitrogen, oxygen. And I want to know what the empirical formula is for PABA, we'll call it. We don't have to call it para-aminobenzoic acid. We're just going to call it PABA, okay? All right, the first thing I got to do is I got to take the amounts that they give me, okay? So it says it was 61.31%. That's grams, or you can just leave it at percent. It's fine, you guys. You don't have to. And you divide by its mass from the periodic table. This 12.01, and again, you don't have to do 12.01. 12 is fine, as far as I'm concerned. But this comes from the periodic table. So I take the percent they give me, and I divide by the mass from the periodic table. So I know in this, I have 5.105 moles of carbon. Okay. Hydrogen, again, I take the percent they give me, and I divide by 1. Again, you don't have to use 1.01, you guys. They did. Okay, you'd get 5.14 or 5.09. And again, it all works out. If you don't round like this all the way through, it still works out the same. Nitrogen, you take the percent they gave you, 10.21, and you divide by 14. That's its mass from the periodic table. So these numbers all come from the periodic table. And again, what you're doing is you're finding the number of moles in this substance, okay? So I've divided them all out. Okay, now I look at them and I go, okay, I got to put the smallest number on the bottom. I'm going to set up a ratio with the smallest number on the bottom. And of these numbers, this is going to be the smallest number. Then I'm going to put the individual ones on top. So I'm going to go 5.015 divided by 0.7288. And I'm going to go 5.09 divided by 7.288. And then I'm going to take 7.7288 divided by 0.7288. That one's 1, you guys. You don't have to use your calculator. My mind works like, I'm brilliant. I can figure that out. And then I'm going to take this number, 1.456, and divide by that. So I think that's my next slide. There we go. Okay, so when I divide these out, okay, I get 7.005. We can round that to 7, okay? You guys, if you get a number like if this was 6.5, that you can't round. That's too much rounding. But anytime you get 984, yeah, you can round that to 7. But if you got like 6.5, I wouldn't be able to round that. And I'll show you on the next example what you do when that happens, okay? Obviously, this is going to be 1 and this is 2. So we got 7, 7, 1, 2. Well, there's our subscripts. C was 7, H was 7, and O2. This is the formula for PAVA. Okay, so you take the amount they give you, you divide by its mass from the periodic table, and that gives you its moles. Then you set up a ratio with the smallest number on the bottom, divide them out, and then that gives you the subscripts. And so that's the formula. Okay, here's another one. Okay, empirical formula for a compound composed of 89.14% gold, sorry about that, and 10.8% oxygen. Okay, this one's only made out of 2. We need to find the formula. And again, these percentages easily can come from one of those big fancy machines. Actually, we have one of those, guys. We have a mass spectrometer. We could be like Abby. Oh, I got it right on my shirt. I love Abby. She's the best. Anyway, so much for that aside. Okay, so we're going to take gold, 89.14%, and we're going to divide by 197. That's its mass from the periodic table. Okay, and when you do that, you get 0.452. That's the moles of gold. Okay, then we take our oxygen, 10.8, and we divide by 16. That's its mass from the periodic table. And we get 0.675. Okay, so now we got our moles. So now we got to set up a ratio. This is the smallest number, so I'm going to divide both numbers by this number. Okay, so this one's obviously 1. That's pretty simple. So the ratio of moles for gold is 1. For oxygen, it's 1.5. Now, some people say, well, I'm just going to round that up to 2. You can't do that. That's too much rounding with these. You're going to get the wrong number. Okay, so when you get like 0.5 or 0.833, okay, or 0.75, that's too much rounding. You can only round when it's like 0.9, okay? So what I'm going to do is I'm going to double both of these. I'm going to make this 2, and I'm going to make this 3. I'm going to double them. Whatever I do to one, I have to do the other. So if I do that, if I double this, I get 3. That's a whole number. Well, if I double this one, I got to double, that's 2. So since I can't write a decimal, I can't write it as AU 1.5. If I double them both, then my formula would be AU2O3. And that's what you have to do when you end up with these. Okay, if I had 1.33, then what I do is I triple them. This would end up being 4, and this would be, this would be 6, and this would be 3 or whatever. Okay, so when you're doing these, you guys, you have to be careful. Most of the time they come out to close, excuse me, close to a whole number. But if they don't, you're going to have to do something. You can double them or triple them, whatever it takes to make sure that you have 2 whole numbers. Okay, so the formula for this compound would be AU2O3. It'd actually be gold 3 oxide. Okay, that's how you do empirical formulas, and that's all we're going to do today. The next lecture, we're going to start talking about units that they measure in chemistry, moles and Avogadro's number and all that. So I figured I'd wait on that, and we'll just do empirical formulas today. So that's what your assignment will be on. Good luck. And I will have another PowerPoint, not one that I did, but I found on YouTube. If you're not getting this empirical formula, simplest formula, you can go through that. If you figured it out from me doing it, you're good. Don't worry about it. You don't have to do it again. But it's there for you as a resource. So good luck, and I'll talk to you soon.